What's going on, everybody, and welcome back to another Geeky Gecko Creations video. So in this video, we're going to cover four main things. And I apologize for the light back here and stuff. I just like when a room is lit with light, right? Also, my wife hates the mustache. Let me know what you think in a comment below, please. So the first thing we're going to cover is, when did we get lemon frost? How many did we make? And when did we stop breeding them? The second thing we're going to cover is the UCLA study, which is world famous. This is a peer-reviewed, published, world famous study for the lemon frost gene, talking about the relationship between it, tumors, and cancer. The third thing we're going to talk about is Dr. Longua Guo. That's the way I pronounce it. It's probably the wrong way to say his name. Very renowned doctor for the study of cancer research in animals, specifically in this case, leopard geckos. His final thoughts on the matter. And then I'm going to drop my final thoughts on the matter. Okay, let's get into it. So here you can actually see when we started lemon frost, because I did an unboxing video, unboxing 3 lemon frost and explaining the future of the project. You could see this video was from December 7th, 2020. So that's pretty much like the beginning of 2021. Now, these geckos were 3 males that I picked up, and you could see it in that video. I named them Lemo 1, Lemo 2, Lemo 3. So if I was to go down this right column here, you would see when and which lemons were bred to what females in this column here. And you'll see all these guys for the first few months were bred to pure Turkmenicus, and then we went into Fasciolatus and Afghanicus later on. But I just want to show you the first pairing took place February 14th, 2021. And the last pairing took place April 7th, 2022. So February 21 to April 7th, 22. Only 1 year. Within that 1 year, we produced a couple generations further of Turkmenicus lemon frost outcrosses, 1 generation of Afghanicus lemon frost outcrosses, and 2 generations of Fasciolatus Turkmenicus lemon frost, which was by far the most successful version of the outcrosses. But I just wanted to show you the dates so you could see we only bred for just about 1 year. I'm going to actually, at the end of this video, I'm going to show you every single lemon frost that we have so that you guys can see what we are seeing over here and can at least know that we're not looking at bad, unhealthy animals. Now, please stay till the end of the video, because although I say we're not looking at bad, unhealthy animals, I have a lot to say about the lemon frost project itself and Voldemort, right? You remember how, like in Harry Potter, you don't even want to say Voldemort's name? And we're going to talk about that a little bit with the lemon frost, because it does have a lot of bad like stigma attached to it. And I'm going to talk about like the ramifications of that, what has brought us a lot of heat and a lot of drama, and whether I think that people should mention Voldemort's name anymore or not. But I did the math here. Right now in the Gecko Lab, we have 62 visual lemon frost, single copy. We never bred any homozygous double copies because it is an incomplete dominant gene, meaning 1 copy makes the animals look a certain way and 2 copies makes the animals look an enhanced way. That's what incomplete dominance is. I'll leave a link to our genetic series below if you want to learn about recessive, incomplete dominant, dominant, all that kind of stuff. So we only bred 62 visual representations plus 8 that I had to put down because their expressions of tumors were getting a little bad and I didn't want them living with that. So I did have to put those animals down. And then I think I sold 1 or 2 to a couple friends during that time that just wanted one as a pet and wanted to observe along with me. Now, I can go into a long story about that. I was wrong about this. I actually listed them in bulk on Morph Market and my website just because people were telling me, hey, you can't do it. And so what did I do in my stubbornness? If you haven't seen my stubbornness video, check it out here. I'll leave a link to it in the description below and also in the top right corner. I was stubborn. And when people were telling me that I couldn't do something, I was just like, who are you to tell me what I can and can't do, right? And that was the wrong mentality to have. I definitely agree. But we have not sold any more than those 1 or 2. I can't even remember. It might have only been 1. And I still have people today that ask me for some. And I'm like, no, I'm just observing them. I don't want these out there. I'm just observing the 62 that I have left. To anyone who has ever said that we're selling hundreds of these and producing hundreds of these, you could see right here, we've only ever produced 62 of them. And I'm going to show you all 62 of those. So if we were to go back and look at every one of these lines, it would basically add up to approximately 62 plus the 8 that we put down, plus let's just say I sold 2 of them. So that would be about 72 visual expressions total, right? Now, some of these were non-lemon frost because it is an incomplete dominant gene, very similar to max snow. If you breed a max snow to a non-max snow, you're going to get 50% snows, 50% non-snows. The ones that were non-visual representations, they have no problems whatsoever because the issue is stemming from something to do with the visual representation, which we will get into in the UCLA paper. But I want to also show you guys something real quick. If you look right here, lemon F81, that means that that was the 81st lemon frost female that I ever produced. So we only produced 81 females, including non-visual versions. So all the non-visual versions, I put those under the lemon frost category. I called those lamos just because I wanted to keep track of those specifically. And if I was to scroll up here a little bit, you would see that we produced 38 males. Now, technically it's 38 minus 3 males because the first 3 males were the ones that I bought. So technically 35 males, right? So if we take 35 males produced plus 81 females produced, you get 116. And this is visual lemon frost, but also including non-visual lemon frost. So this 116 minus the 72 visual lemon frost means that we produced 44 just wild type outcrosses. And there's nothing wrong with those wild type outcrosses. They have nothing to do with the lemon frost gene because only the animals with the lemon frost gene are the ones that have the issue. So let me minimize that. Now you can see that we only ever produced about 72 single copy visual lemon frosts. Now I did a little bit of an update here in February 26th of 2023. I don't have many videos of lemon frost out there, but I did a little bit of an update in this video, just kind of showing off some of the lemon frosts and the rack that we were keeping them in at that time, which is actually still the same rack. So the lemon frost are completely separate from all our other projects and lines. They don't ever interbreed with our other projects. I was only studying the outcross lemon frost. When I bought into the project was in the 3rd or 4th generation of outcrossing to Turkmenicus. And we were seeing a lot of success. The person who I got the project from, no big tumors, no big bulges, anything like that. Because when I first heard about lemon frost, I was like, oh, I want nothing to do with it.
Ugh. Brother, ugh. What's that? What's that, brother?
I had a couple Enigma leopard geckos that spun around in circles, starved themselves to death, and died. And so I was like, no, I can't handle that. And when I saw the lemon frost with the big tumors and stuff, I was like, oh, no, that's not for me. But then when I saw a healthy looking lemon frost, it was a completely different story. And I said, maybe there's something here that we're not looking into, something that we missed. And kind of like the scientist geek in me was like, oh, I want to see this through. So you can see this is one of the males that we got originally. This was a generation 3 outcross, meaning its grandparents were lemon frost to Turkmenicus, that baby to Turkmenicus, that baby to Turkmenicus. So it was in the 3rd generation. And so I bred 2 more generations into the 5th generation, outcrossing it to Turkmenicus to see if that made any difference because there was already a lot of success in generation number 3. The geckos here don't have thick skin. They weren't developing big bulbous tumors. And you will see there are a couple of them that do have like some bright white patches and a couple that did develop tumors, which obviously those are the ones that I put down. But a lot of those were macularis or Afghanicus. So in our pairings, macularis and Afghanicus produce the thickest skin. And whenever you have the thickest skin and the most colorful pigment, I know that lemon frost is based off of an overproduction of white cells and reflective cells, but I can tell you from observation, the animals that have more color naturally, such as Macularis and Afghanicus, that have a richer saturation of yellow color, those are the animals that express more. And the animals that have less pigment, like Fasciolatus is the most reduced pigment because it's very light colored of an animal, almost looks like a Max Snow, and so is Turkmenicus. Those animals have the least problems. And between those two, Fasciolatus is way better, in my opinion, way better. That's why I actually stopped Turkmenicus. Once I saw the first generation of Fasciolatus, I no longer bred Turkmenicus. And that's when I bred a second generation of Fasciolatus to see what would happen in the second generation. And we're going to show you every single one of those geckos by the end of this video so that you can see what we're seeing and the results that we came to see. So lemon frost is characterized by thick skin, tumors, and then super lemon frost actually have cancer. Not regular lemon frost, but super lemon frost. And we'll show you that in the UCLA paper. But the Turkmenicus, if you look at this gecko right here, this gecko does not have thick skin. This is a normal skinned gecko. And this is what we were seeing with Turkmenicus, as well as especially Fasciolatus, So now that you kind of are caught up with how many we produced, the fact that we only bred them from 2022 or 2021 to 2022. I'll show that to you one more time. The first pairing was February 2021. The last pairing was April 2022. So 1 year and 2 months. And within that 1 year and 2 months, we bred 2 more generations of Turkmenicus outcrosses, 1 generation of Afghanicus outcrosses, and 2 generations of Fasciolatus outcrosses. We only produced 73 or 74 visual single copy lemon frost when you consider the 1 or 2 that we basically just gave away to a friend for cheap, like $50 or something like that, the 8 that we put down, and the remaining ones that we still have now. And of the 8 that we put down, they're all Macularis based or Afghanicus based. There might be one of them in there that is Turkmenicus based. I'll check that out when I go into the garage. I'm keeping them frozen in the freezer so that I can do my own dissection later on at a future point and just kind of verify what the UCLA study verified already, which is that single copy lemon frosts do not have cancer. They do have the ability to produce skin tumors, but not cancer. That's only double copy homozygous lemon frost. So let's now get into Dr. Longua Guo's study, because this is really amazing. So there are quite a few notes here that I do want to touch on. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different features of his paper that we are going to cover. Sorry, I have to get myself some water here, talking a lot already. Okay, so this study is publicly on the internet. It is peer reviewed, meaning this is legit. In the scientific community, this is legit. Even though the paper does not come to a full 100% conclusion, which we are going to see near the end, it is a legit peer-reviewed scientific paper that the doctor and his team spent over $100,000 on tests for this study. When the original lemon frost was tested, Mr. Frosty, he was donated to the scientist over here. And the scientist, you can see right here, they bred and studied a colony of more than 900 animals. So do you guys see that? So they bred 900 lemon frost for this study. Of that 900, it doesn't say which ones are super, which ones are visual, which ones are non-visual. It might have said that. I'm going based off of my memory when I last read the paper. I'll leave a link to this paper. You could certainly read it in the notes below. I'm pretty sure they do not say how many of these 900 were single copy, double copy, or 0 copy of the lemon frost gene. It does say, however, that they were bred to, let me establish this first, actually. It was determined that based on the sequencing of the gene, lemon frost is a single locus Mendelian inheritance. So it's only taking place at one locus on the gecko's DNA, where the errors are that are causing the issue. At least this is what they're placing forward. And the homozygous forms, which are 2 copies of the gene, have more pronounced phenotypes or visual expression than the het forms, or the ones that are only 1 copy. This is another reason why I was so into outcrossing in the beginning, because when you look at this study, here's Mr. Frosty right here. And if you read this statement right here, Mr. Frosty was bred to 12 female leopard geckos from different genetic backgrounds. So like Blizzard, all that stuff. They don't mention every single one of the 12 in this paper, but he was bred to 12 different females. And then those babies were bred back to each other and back to their parents. So it was a heavily inbred project. If you look at this, Mr. Frosty plus the 12 females at the top here produced this bunch in the middle. And then this bunch in the middle was bred to each other and back to the parents to produce this last observation bunch, because this study took place for only about 3 years when the paper was finished. And so all the breeding and stuff had to take place within only 2 years, because then after that, they had to observe the animals, write the paper, get it published. And the paper was published January 27th, 2021. So basically, by December of 2020, there was already rumors circulating that this paper was coming out. And then by January 27th, 2021, this paper came out. But if you dig into the history of this paper, they only bred for about 2.5 years. And then the last 6 months were them like publishing the paper, making their final observations, and eventually in January of 2021, publishing the paper. All right, so now let's move on here. This sentence right here shows that the lemon frost gene is basically responsible for producing an increased number of iridophores and reflective platelets. I don't know if I'm pronouncing that correctly, with each iridophore. So basically there's an overproduction of cells that are going on here and a lack of those cells to naturally die, which is why they turn into tumors and just replicate on top of each other in some cases. And that's going to be a big hinge that this door is swinging on, is why doesn't it take place all the time? If this is an issue, problematic area, why doesn't it happen with every single lemon frost? But first, notice that in addition to skin and other affected organs, right? Heart, liver, all that kind of stuff, in homozygous mutants, they call them mutants, which is interesting, but homozygous mutations, which, remember what homozygous is? Super lemon frost, 2 copies of the gene. So affected organs in homozygous only mutants include liver, eye, and muscle cancer, basically, because right here, the interpretation of widespread nodules is that the tumors are malignant and iridophoroma, but only in the homozygous form, not the heterozygous form, at least from what they're showing here. They are not saying that the heterozygous form actually has cancer on the inside, which is why I held 8 of those back in my freezer right now, so that when the time is right, I can dissect them and look for myself. But I have talked to other respected elite members of the reptile hobby, veterinary type people with very good reputations that have done their own studies dissecting these animals as well, and noticing that the single copy also does not have cancer. So let's just go with this for now, right? The homozygous only, out of these 900 animals, the homozygous only were the ones that were determined to have the cancer. So double copy genes. We never bred any homozygous because our theory was, if we can't fix the heterozygous, why even bother going down the homozygous? So here's where it gets really interesting. In macularis only, because this study does not say that they studied Turkmenicus, Fasciolatus, or Afghanicus, and we're going to get to that in one of my next points coming up, more than 80%. So what does that mean? 81%, 82%, 80.5%, 90%, whatever that means. Let's just give the benefit of the doubt. 85%. 85% of male and female lemon frost develop white tumors, not cancer, because tumors and cancer are 2 different things. Technically, a mole is a tumor, right? It's just a cluster of cells that are not dying. 85%, Even though this only says 80%, it says more than 80%. So let's give them the benefit of the doubt. 85% within 6 months to 5 years after birth develop white tumors. Now, the interesting thing here is that in their study, the generations that they talked about being bred, they only bred them for 2.5 years. So where are they getting this 5 years after birth from? They must have taken information from other breeders, or when they took in a mass amount of animals for this project, some of them were taken in from the breeder that was working with them, and those animals were counted towards the project, and other animals were bred. Or the lab just used all the animals from this breeder and studied them for 2.5 years. This paper is a little unclear which route they actually went, but regardless, 80%, it's given the benefit of the doubt, 85% of animals carrying the gene develop tumors. What about the other 15%? That's a lot. If I told you, hey, there's a 15% chance tomorrow that it's going to snow, that's a huge percentage when you are calculating your plans for the next day. 15 to 20% of animals don't develop tumors. That was geeking out my head when I was first looking into lemon frost. And again, I wanted nothing to do with lemon frost because of the way they looked. I mean, look at this. This is terrible, but this is not what I was seeing. This is not what I am seeing right now. And this is not why I originally bought into the project. I bought into the project because this was not happening. So that's a key note there to take note of. So take note of this. After spending $100,000 and studying 900 lemon frosts, we don't know how many of those are non-lemon frost, how many of those are lemon frost, how many of those are super lemon frost. But after studying 900 animals, Spint 1 is a strong candidate. Okay. So what if I said to you, viewer, right? Because you're watching right now, viewer, you are a strong candidate for presidency. It doesn't mean that you automatically are president. It means that you're a strong candidate. So you have to be very careful when you read scientific papers like this. This is a huge hypothesis statement. Spint 1 is a strong candidate. Okay, so it's a strong candidate, but it's not 100% the cause. And when we look at this right here, Spint 1 was discovered to also have tumor-related issues in zebrafish and mice. And the reason scientists are studying this is because they want to see the human application. You know, our DNA is very close to like mice DNA and stuff, which is why they do a lot of experiments on mice and rats and those kinds of things, right? For diseases and disease prevention when it comes to human beings. So if they could fix and understand what's going on with the tumor production in a zebrafish, a leopard gecko, or a mouse, in this Spint 1 gene, which is a strong candidate, they could apply that research to human studies and help to cure cancer for humans. So the lemon frost Spint 1 differs from the reference genome at 2 locations. So the lemon frost gene differs from a normal leopard gecko that does not produce tumors in 2 locations. There is a large number of variants in this sequence between the lemon frost, Mr. Frosty, and a non-lemon frost, leopard gecko. But look at what they say right here. This makes it challenging to identify the causal mutation. So they have not identified the causal mutation. They've identified an area that is suspicious, right? Spint 1 is a suspicious, strong candidate area for this problematic lemon frost gene, but they haven't actually determined what is the cause, right? When you talk about cause and effect, if I snap my fingers, they will make a sound. That's cause and effect, right? The cause is snapping my fingers. The effect is the sound that is being made. They don't have that with lemon frost. They don't have a cause. After spending $100,000, 900 animals, 3 years studying, this is their final remarks. Because of how many differences in genetic background there are, it makes it difficult and challenging to identify the causal mutation. All right, let's keep moving on. I got 2 more points of reference here. Several lines of evidence support our hypothesis. So let's look at that one more time. Hypothesis, right? Let's look at the definition of hypothesis real quick. A proposed explanation made on the basis of limited evidence as a starting point for further investigation. Swing on that hinge, further investigation, because that's going to tie into one of the clips that I show you of Dr. Longua Guo here.
So we were not able to identify the mutation. Of course, as we discussed earlier, we will need more animals. A lot more animals.
Several lines of evidence support the hypothesis that a defect in SPINT1 causes cancer. Iridiopheroma is cancer in lemon frost geckos. Okay, we got a strong candidate. We got several lines of evidence, but what is this? What is this paper proclaiming? This is only a hypothesis. And I'm going to confirm that with an interview that Dr. Longua Guo did a year after this paper was released, or 2 years after this paper was released, with Evan from Strength and Leos. And you can hear from the man himself that it was truly a hypothesis. And they have not yet discovered what the actual cause was, and they need more animals to study, according to the doctor, to figure out what the cause actually is.
So we were not able to identify the mutation. Of course, as we discussed earlier, we will need more animals. A lot more animals.
Now, it doesn't mean they're going to get more animals to study. So hang tight in this video. If you're waiting for Frank to say everyone should breed lemon frost and stuff, then you might be disappointed, or you might not be disappointed, because I want you to stick around to the end. But I got a lot more points to make here, and I would like for your guys' feedback on it and understanding of where we were coming from when we were continuing the whole lemon frost study that was started 3 years before we even jumped in. White Iridiopheroma is common in many reptile species. I just want to show this to you. Iridiopheroma, which is cancer of these white chromatophores or pigment cells, includes green iguanas, snakes, bearded dragons, and veiled chameleons. So those are just some other species that I wanted you to see that actually have a tie into iridiophores that can get cancer. Because I don't know if you guys have ever had a random reptile just get tumors, but reptiles get tumors. I took a snake to the vet, determined to have a tumor. We had a leopard gecko that was gifted to us by a friend, had a big tumor. Of course, it was like a blizzard. It wasn't even a lemon frost or anything like that, but animals get tumors just like humans get tumors. So I just kind of wanted to end with that note as far as the UCL paper is concerned. This is a long paper, not super long. If you want to read it, I will leave the link in the bio below. Make sure that you click on full text right here, because a lot of times the link leads you to the abstract, which is only a portion of the paper, whereas the full text is the actual full text. Now, fair warning, this is a very scientific paper. So you kind of need a scientist to break this down with you, or a medical expert. I am not a scientist or a medical expert, but I was going based off of the observations that I saw in the 3 years that this project was worked before I bought those 3 males. Because remember, I only jumped into this project because I visually saw no thick skin, no tumors, no shortened snout. A lot of lemon frost have a shortened snout, a shortened body, and we were not seeing that in the Turkmenicus line. So that's why I wanted to further study the Turkmenicus line, as well as the Fasciolatus line and the Afghanicus line. So that's Macularis, Turkmenicus, Fasciolatus, Afghanicus. I did not study Montanus. I don't have a desire to study Montanus. I will give you my conclusions at the end of this study, and we will take a look at every single lemon frost that we have. I want to play you a clip from Dr. Longua Guo, Mr. G himself. This is a very long video. It is on Strength and Leo's channel. Give him a subscribe. He has a lot of cool leopard gecko people that go onto his channel. But this session in particular is with the doctor. This is the doctor that it was in charge of the UCLA paper. The 900 animals, the dissections, the super lemon frost, the publication. This guy was at the forefront of all of that. This video goes into a lot of detail about the lemon frost, and it goes across different topics. But there was one part that I want to bring out for you, which we will listen to now.
So for the lemon frost, a lot of people think they have ideas not based off research, but that
Wait, I'm sorry. I forgot to tell you when this came out. So November 2022. Now, Evan is actually referring to me and others in this hobby that wanted to outcross the lemon frost to healthier bloodlines and even wild type bloodlines, such as Turkmenicus fasciolatus afghanicus, which Dr. G's study was not focusing on. Remember, their study was 900 animals that were produced by breeding one problematic male to 12 females and then breeding the DNA from that one problematic male. Remember, he's passing on those problematic genes. They're breeding that now to each other, brother, sister, mother, son, father, daughter, for 2.5 years. And they produce 900 in an inbreeding macularis setting. So Evan is going to push him here on whether he thinks outcrossing to healthier lines or selecting the healthiest animals over time could be a solution. And listen to what he says.
The lemon frost can be outbred from the tumors, and the tumors can be, if you cross it to like wild types or other species of leopard geckos, that it could be disconnected. So what do you think about that?
That is a possibility. Yeah.
All right. Technically, that's all I need to show right there. The doctor goes into a long explanation of how outcrosses could be good for the lemon frost study. And you heard it right from the man himself. The guy who made 900 of these for 3 years in a row that published a peer-reviewed paper. And when he's asked, should we try making more to cure this issue and can it be cured? He says yes. I think there's a couple other words after this that I want to touch on, but I encourage you to listen to this full episode.
So it could be a mutation in another gene, which to enhance the tumor suppressor gene of a different gene, which can, override SPIN1's impact.
All right, so let me break that down for you. Basically, what he's saying is there could be other genes at play that are affecting why some lemon frost have very bad expression of tumors and other lemon frost have zero expression of tumors. And that's why he was saying that outcrossing could work.
But it could also be epigenetics. Epigenetics means like it's not necessarily a mutation of a particular gene, but the modification of the genome that may be able to inherit through to the next generation or may not. So I definitely advise the breeders pay close attention if they do continue the breeding to these phenotypes. Take very good records, very careful records, and keep those.
So you can see right here, he's very hopeful. The scientist in him is very hopeful that because they did not find the exact cause, he wants to find out what is actually causing this. There could be other genes at play that are affecting the SPIN1 gene and making it better or making it worse. And so by outcrossing and stuff like that, he's basically saying, if you are breeding these animals, study them, because some of them are going to express well and others of them are going to not express well. And if you listen to this complete episode, he talks about a lot of other things lemon frost related. That was the one point that I really wanted to focus on right there, was to show you that even a year after this study was produced and 900 animals were made in this study and they saw the worst of the worst stuff, the doctor was like, yeah, it can be cured. It's possible, right? A long time ago, somebody said, I want to go to the moon. And other people said, no, it's impossible. And what happened? We went to the moon. Somebody recently said, we want to go to Mars. And a lot of other people said, why? We got enough problems here on Earth. Let's just focus on that. And now we have a mission to Mars already planned. So when it comes to the world of science, there's always going to be pushback from people that don't agree. But the scientist in every single one of you guys and in Dr. G over here, I think there's a piece of that inside of every single one of us that wonders what if, right? And how can this be possible? Is this possible? Because when humans are involved in the picture, we've proven that almost nothing is impossible when we stick together and when we put our minds to it. Okay, so like I said, I do encourage you to watch this whole video because he does talk about the topic in detail, as well as regeneration and why they're studying leopard geckos' ability to regenerate their tails, or geckos in general, and how that could apply to human study research. So the bottom line here, though, is they're very interested in lemon frost and leopard geckos because it could have a huge implication and application to human trials and research in curing cancer or making cancer better or even preventing cancer, right? We have genetic splicing nowadays, which means you could remove a bad part of DNA and put a good part of DNA in it. And I'm not saying whether I agree with that or disagree with that. I'm just saying that when you find the causes for an issue or a problem, you can remove the problem and place in fresh DNA, new DNA to create a solution. And essentially by outcrossing, that's what we're doing. We're trying to have the bad genes removed that are contributing to the issue and replace them with good genes. And myself, as well as others that came before me, thought that it was best to do that by outcrossing the lemon frost to separate species or subspecies like Turkmenicus, Fasciolatus, Afghanicus that already have a slightly different set of DNA than the traditional macularis. All right, so we have went through why I started, when I stopped, the UCLA study, what the doctor's final words were a year after the study. Now I want to give you my final words. I've been talking to a lot of people recently, and if you guys missed my apology video that I put out, I will also leave a link to that here. I just really wanted to apologize for anything that could have been like me allowing my scientific side of my head to get the better of me and curiosity. Because I knew all of this. I knew that outcrossing works. I knew that the UCLA paper did not come to a conclusion, but rather a hypothesis. I knew that they didn't find the causal root of what is actually causing the problem. And I didn't know that the doctor would support outcrossing, but it was nice to know a year later that he confirmed what we and many others were already doing, which was outcrossing and selecting the healthiest lines back to repair. But I do need to give my final thoughts on this matter. And it's going to be short and sweet and to the point. Even if we cured lemon frost, nobody would be a part of it. And I hate making an absolute statement like that, but there is so much negativity attached to lemon frost. Nobody will mess with it. So by messing with lemon frost, you are only going down a very lonely and painful road. If there's anything you could learn from me and the mistakes that I have made publicly in talking about lemon frost, I didn't ever promote it where I told people that they should buy it or anything like that. A matter of fact, I was the one that got lemon frost banned from Morph Market because when I put a bunch of them for sale on Morph Market because people told me I couldn't, which was wrong of me, John actually reached out to me and he did research on the matter. He talked to other people involved and he was like, yeah, this isn't best for our platform. We are going to ban lemon frost from Morph Market. But he did it in a very respectful way. And he even thanked me for being understanding. He was like, look, I understand this is a study of yours and it's never nice to have a project just outright banned from our platform, but it's what's best for the platform. I thought he was super mature and responsible in the way that he dealt with me. So to all you guys who are glad that lemon frost was banned from Morph Market back then, it was because I put them on Morph Market that they were banned. Because before I put my lemon frost on Morph Market, there were other lemon frost on Morph Market, but nobody with as much drama attached to their name as myself. So nobody caught backlash for it. But when I put my stuff out there, everybody jumped on John and they were like, John, you got to stop this. And John put a stop to it. But first he did his research. He talked to everyone involved and he came up with the decision that it wasn't best for Morph Market. And I actually agreed with him. I sent him a message back saying, look, I agree with you. And I do apologize for putting them on Morph Market and putting them on my website at that time, just to spite everybody, to show them that they couldn't tell me what I can and can't do. That was immature and childish of me to do. But it got lemon frost banned from Morph Market. So that was one good thing that I think came from it. Because I don't believe lemon frost should be on Morph Market. I don't believe it should be like bred and sold regularly by any means. The only reason I was working with it is because I had a controlled group that I wasn't releasing. Like I said, I released maybe one or two of them to a friend for like $50 or something that just wanted to study them along with me. and keep them as a pet. And then that was it. I kept the rest of them, and I still have the rest of them, which I will show you at the end of this video. So my final words on lemon frost are that even if myself or somebody was to completely cure it, completely, 100% genetic splicing or whatever the case is, this is just my thoughts. So I'm going to say this passionately because this is just my thoughts and I want to make my point clear. Lemon frost will never be accepted, and it will always bring you down, and it will always bring out the worst in people to make accusations against you. It will never be accepted. So it is not worth working with. There's a lot of other genes that we could get that are similar to lemon frost, like white and yellow, and you can mix white and yellow with wild types and do all kinds of cool stuff. Obviously, we have tons of other genetics in leopard geckos, and we're coming out with more combinations and morphs on a daily, monthly, yearly basis. So there really is no reason for us to be breeding and selling them. Like I said, my last pairing was 2022. I showed you April of 2022, April 7th of 2022. I have not bred any since then, and I don't have plans to breed any now. I don't have any reason to put down the animals that I currently have because they are healthy, they are beautiful, they are sweet animals, and I don't have the heart to do that. So I will show them to you guys now, and we can see the results of everything that I've poured thousands of dollars and my blood, sweat, and tears and reputation on the line into over the last couple years. And I will let you guys be the judges. I'm interested to see what you guys think below. So please take this as an opportunity to let me know. All right, guys, welcome to our humble little abode. So we are currently converting all of our 6-quart tubs to this style rack right here. So I'm very excited for that. And then we also have our adult breeder 28-quart tubs. You can see that how easy it is to like move around. They're all on wheels. They have these holes here in the side so you could use heat tape if you need it. Beautiful. Really excited for these. I'm currently have maybe like, I don't know, 6 or 8 of these made, maybe 9 or so, and I need to make like 10 more. So I ask that you please be patient with me. I want to show you where we have the lemon frost. So this right here down is the lemon frost, and that's how we have 60. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 5 across is 60, plus these 2 down here, plus the 8 in the fridge, which I won't show you. I don't think there's need to show you. Man, my mustache is really coming out now, that caterpillar on there. But this is what we're gonna go through. So as you can see, the lemon frosts are in their own rack. They're not intermingled with anything else. They're not bred. They're simply just observed. And I'm going to show you every single one of them now, so there could be no questions over the condition of them and what we are working with. If there is one that has like a little bit of a bad tumor, maybe on its neck or something like that, like I said, most of those are the macularis ones, which we did produce like 1 pairing of macularis ones, so a couple visual macularis, just because we needed to personally compare that to everything else that we're seeing in person, such as the Turkmenicus, Fasciolatus, Afghanicus. Those are usually the ones that are bad, the macularis and the Afghanicus. So if there is one that is bad, I might not show it. But like I said, the 8 that were bad, I already put them down. So I don't think we're going to come across too many bad ones here. And I just cleaned these guys all the other day and took a look at them. So I think we should be good. But I'm doing this live without first looking at everything, because I want you guys to be able to like record along with me, right? All right, so I think this should work. The lighting is really good and everything like that. So I'm just gonna start going through them one at a time. All right, so this is the first one. This is Turkmenicus Lemon Frost. I have the genetic information for all of these guys on their ID labels, but obviously I don't have my computer with me, and it would take me forever to look up which ones are from which dates and whatnot. So I'm just going to say what I think off the top of my head this is. So Turkmenicus Lemon Frost generation 3 or 4. Turkmenicus and or Fasciolatus Lemon Frost. Again, I don't have my computer with me, but you guys know that we bred about 2 further generations of Turkmenicus, and then we bred 2 solid first and second generations of Fasciolatus. But beautiful, beautiful animal. And as you can see, these guys are like really healthy. So I don't want to put these guys down if I don't have to. And I don't think any of you guys would want me to put these guys down. Just so you could see also, no white spots under the belly or anything like that. Like how the Macularis get it. So if I had to guess, this would be Fasciolatus turkmenicus generation 1. Because like I said, the Fasciolatus are the best by far. Now here's an interesting one. This is actually a Black Knight, which is Macularis turkmenicus. So this is Black Knight bred to a Turkmenicus lemon frost. And also, no issues. Oh, right there. You can see right there. You see that bright little bubble right there? So that is a tumor. It's an overproduction of cells that are not dying, so they're bubbling up on the surface. A study in Finland too, which I wanted to go over in my video earlier, but I had trouble finding it in my bookmarks. But there was a study in Finland also that said that these tumors are non-painful to the animals. I don't want to argue that point or fight that point, but in the same way that like a mole is non-painful to you unless it becomes cancerous or something like that, that's basically what they determined for these guys. Now, the ones that get really bad where they have like big ones that interfere with their eyes or ears or something, those are the ones that I put down and don't want them to live. But something like this, super superficial. Look, this animal is in no pain whatsoever. There's no reason to put this animal down. None whatsoever. Wow, look at that stare. Beautiful. Here's another Fasciolatus turkmenicus lemon frost. Look at the beautiful yellow on the face. Like, compared to the head. Isn't that really interesting? So you can see no white spots underneath. And all of these guys are going on 2, 3, 4+ years now. Because obviously the last ones that we produced were in early 2022 that we hatched out. And it's already early 2024. So even the last of the ones that we produced would be about 2 years old. And then the first ones we produced would be about 3 years old. And then the original 3 males that we got would be about, let's just say like 4 years old or so. But very beautiful animals. Definitely a Fasciolatus turkmenicus one here. And the reason I say turkmenicus is because if you remember, when we bought into this project, they were already 3rd generation Turkmenicus. They were already 87.5% Turkmenicus and only 12.5% Macularis with the lemon frost. So these are 1st generation Fasciolatus Turkmenicus lemons, but they are predominantly Fasciolatus blood or Fasciolatus DNA. So no issues, beautiful animals, not in pain, not suffering, anything like that. Okay, now this is a Macularis production. Remember what I talked about? Macularis is worse. Can you see here? This is Turkmenicus bred back to Macularis. We wanted to study a couple of those to see if it would make it obviously better or worse. Shorter face, thicker skin. Do you see the thick skin? The thick skin is not good. So if I had to guess, this might be one that we do put down as time goes on. Right now, it does not have any major issues, no pain, no suffering, anything like that. But you could see the formation of like bigger clusters of cells already starting to form. So this is Macularis, which like I said, Afghanicus and Macularis are by far the worst. All right, here's another Fasciolatus Turkmenicus lemon frost. And you can see long face, normal body, no thick skin. You could definitely see no bright white marks, no thick skin compared to the Macularis. And remember, all these guys are the same age. So these guys right now that I'm showing you, they're in the same condition age-wise and stuff as the other ones. And you can see just how different they actually are. Now again, we can and never will sell these guys because the hobby just does not accept them. And so, to be honest, we don't want to be sowing negativity or any drama or anything like that. And so we would rather just get back to gecko content. But I do want to show you guys everything over here. so that there can be no questions about what we have and why we decided to outcross them in the first place based off of how nicely they look, as well as how nicely they still look, right? But I am not hopeful by any means for the project making a comeback, even if it was 100% fixed. There's just no way. All right, this is number 8, Fasciolatus turkmenicus. Very cool. No tumors, no nothing. No thick skin. This is a macularis back cross. And again, what did I say? Short face, thicker skin, the bigger buggy eyes. Now, right now, this animal has no pain points, anything like that, that would give me reason to put, other than being a little jumpy, but reason to put this animal down. It's a perfectly fine, healthy animal. You can see it's not in any pain, not stressing out or anything like that. I could touch it on the tip of the mouth right here. It'll give me a little lick kiss. But this is one of the ones that I would observe as one that I might need to put down in the future. But as of right now, it's perfectly fine to observe and live as a pet and have a nice, long, healthy life with us. So the next one was a similar condition to the last one. And because I don't want to be this, I don't want this to be a video where like we show things that we think are unacceptable for breeding, such as like the bigger eyes and stuff like that. I don't have a need to show it, but it's exactly like the first one, right? So I'm moving on now to this Fasciolatus turkmenicus one, which you can also see longer face, no thick skin, normal looking gecko. As far as, you know, bright spots are concerned or anything like that, there are none. So here's another one. This could even be a second generation Fasciolatus lemon, because it is a little smaller, so it might have been bred more recent, like in that 2022 year or so. And it is more white. So remember, Fasciolatus reduces color saturation. And where we see the biggest problems with lemon frost is in more saturated colored geckos. That's why when you see like tangerines or just regular macularises, they often have short faces, big eyes, lots of bright white spots. All of that is no good. But that's not what we see in Turkmenicus or Fasciolatus. No bright white spots. No bright white spots. No big eyes. No bulbous tumors or anything like that. So as you can see, this project was actually a really good study. I tried to reach out to Dr. G to see if he wanted to study these guys, of why they are expressing in the same way that macularis is. Remember, they only studied macularis for 2.5 years, and they were already big bulbous tumors coming out the neck and all this stuff. So these guys that are 3+ years old already with nothing whatsoever going on, I think there's definitely something going on here, and they could learn from it. So I'll continue to try to reach out to Dr. G. I would never want my animals like put to death if I can avoid it. So maybe if there's a different way for him to study its genome, such as a shed test or something like that, then I could contribute. But these guys, I just don't think there's a reason to put them to death. Maybe that's the right answer. I don't know what you guys think. I don't know what you guys would do if in my condition. A lot of people keep lemon frost as pets already in the hobby, and they have the bad versions. They have the ones that are macularis or very like tumory prone and stuff like that. These guys are perfectly fine. Obviously, I can't give them out to people as pets because that would make a lot of people very unhappy. So I'm just planning on keeping them myself as pets, right? And these guys cost me a lot of money too. It costs me about $2,000 to $3,000 a year to pay for food, employee costs, and housing these guys. Plus, it takes up 62 tubs worth of space that I could be putting 62 other leopard geckos. So these guys definitely don't make me any money. They don't help my reputation. Obviously, there's a lot of people that like condemn me for it and make up lies and rumors about it. So it hasn't given me the easiest time for sure. So I really have no benefit to holding on to these guys other than doing what's right. And I just don't want to see them killed. Again, no white spots. Beautiful. Okay, now the next one before this one had a slightly larger tumor mass on its side that was about 1 centimeter. And so I don't want to show that guy because, again, there's no reason to show that. But it's in a place that does not affect any pain for the guy. It's not next to his eye, his ear, anything like that. This guy's making a getaway here. And this guy is actually Afghanicus, which is really cool because you can see it creates a lot of dark pigment on the animal, giving it kind of like a real Batman type look, right? But thicker skin. Remember, more color means thicker skin. And thicker skin means more issues. So if I was to show this guy, you could already see bright white spots right there. And those bright white spots will most likely never turn into like a bulbous tumor. They'll always stay more like flat into the surface. And they should not become cancerous because, as we saw in Dr. G's study, only the super lemon frost become cancerous. And this guy is not in any pain or anything like that. So there's no reason to put this guy down whatsoever. Okay, now this guy, I'm going to try my best not to show his tail tip because his tail tip is falling off, and we definitely don't want the mobs to come out swinging. But you could see, again, no thick skin, no short face, beautiful eyes. You can see a little bright spot right there. We definitely do not claim that every single gecko does not have a bright white spot or anything like that, because some geckos do have bright white spots. And like I had to put down 8 geckos out of 73, some do have worse expressions that need to be put down. But I'd say the vast majority, especially of the fasciolatus ones, do not. And that was one of the things that our study was meant to realize, is if lemon frost is going to be bred, and it should not be bred, but if it was going to be bred, one of the things that we wanted to make known is what is the highest solution for breeding them, so that people can make healthier versions rather than unhealthy versions, right? And so you can see this guy, no issues. He had a little spot, but for the most part, nothing, right? Nothing. All right, I'm going to stop explaining now and just try to move through these. First or second generation fasciolatus. Nothing. Fasciolatus Gen 1, lemon frost. Nothing. Beautiful animals. Just beautiful. Again, no white spots. This one was a male as well. This has got to be one of my favorite ones. I love the really black ones, right? That have a lot of black contrast. I call them Batmans, right? They just look like very Batman-esque. Nothing. No white spots, even ovulating. And this one is not breeding, because again, we are not breeding these guys. We stopped in April of 2022. Boom. Here's another. Kind of Batman, right? Like dark pigment, no bright white spots, beautiful animals. And one of the reasons I'm showing every single one, with the exception of like a couple, is because I want you to see what we are seeing over here. So many people paint the worst picture possible for lemon frost, when in reality, the ones that we have just look like this. Nothing wrong with this animal at all. Here's another one. This might be a fasciolatus Gen 2. I could just tell because of how light the coloration is. Probably ovulating, yep, because I could tell she's kind of a little skinnier. And sometimes girls that are ovulating are skinnier. Nothing. No issues whatsoever. Here's a big boy. You could see a bright spot on his back leg right there. Most bright spots do not turn into like bulbous tumors. The worst bulbous tumors actually usually happen around the ears, the eyes, or the lower jaw. So those are the areas that you want to watch out for. But when it comes to stuff like that back leg bright spot, it's just going to stay small like that. Very insignificant, does not affect the life of the animal whatsoever. A little bright spot on the tail right there, right? And again, the bright spots are an overproduction of the white crystalline cells that do not die off because there is a suppression problem. There's a problem with the cells dying off, like cells are supposed to. But you can see these animals are nowhere in pain or looking bad whatsoever. Now this was a Black Knight one, a little smaller from the Black Knight genetics, and it's a female. She just didn't really grow so big. You can tell, Black Knight. So it would have been a Black Knight crossed to probably a Turkmenicus one. I have all that genetic information, but it's just not written on the tub because we really wanted to study everything intricately. So all of our information has like the parents, when they were paired, when the baby hatched, all that information. But obviously it's just not on the tub because that's a lot of information to have. And so you can see those bright white eyes, which are very reminiscent of lemon frost. But again, Turkmenicus Black Knight, no issues. This was an Afghanicus one, really interesting, kind of like eyes and a smile going on there. This one obviously came out like a little small, a little runty, which can happen with any leopard gecko whatsoever, but this one just happens to be Afghanicus, Turkmenicus, lemon frost. But look at that face on the side there, really interesting. And obviously really cool pattern on the top of the head, which tends to come from the wonkiness of the Afghanicus, and then kind of like the spread out pattern of Turkmenicus. But nothing major, nothing a major deal with this one whatsoever. So no reason to put this little one down at this moment. Here's another Afghanicus. They look so cool because of how dark their pigmentation is, but if you look at this animal, it does have thicker skin. And again, the thicker skin is not what you want to go for. So look what happens ovulating, but look what happens with the thicker skin. You can see like more white spots building up. There's one on the back right there. But again, no pain or nothing to the animal. There's no reason to put this animal down right now. These tumors are very superficial. They're only on the surface. And so if it's not interrupting with the geckos eating, drinking, sleeping, like anything like that, there's no reason to put them down if the tumors are minuscule, small, and not bad. Another one without any problems at this stage in life. So we have no reason to put this one down right now. Okay, so this is actually one of the very first ones that we brought in. And so this guy is, I think he was born 6 months before I brought him in. So if I brought him in December of 21 or December of 20, then he would have been like a summer baby or even a spring baby of 20. So spring 2020, we just passed spring 2024. So that would make this guy 4 years old. And he had one bright spot ever since he was 6 months old. You can see that one bright spot right there. And it's never gotten any bigger or any worse. He's never developed any more spots or anything like that. This is basically a generation 3 Turkmenicus lemon frost. This was the reason why we brought in the lemon frost. Very long face, very long body, not thick skin. If you rewind this video, this guy does not have thick skin compared to like the Macularis, Afghanicus. Those were all really good signs that we were looking at for this project originally. Here's another Fasciolatus lemon frost. This one's really, really nice. Like no issues whatsoever. No bright spots. So these guys are really nice, really good. The Fasciolatus is the one that I had the most hope for when I saw the first generation of them originally. Because again, we knew the biggest issue with these guys is the thick skin. The ones that have thick skin always produce tumors. Like the ones that have thick skin always produce tumors no matter what. So we were looking for animals growing up that did not have thick skin, and that was mainly the Turkmenicus. But then the Fasciolatus quickly became the best. And so you can see a little bit of a bright spot right there. And this baby was actually born with a little bit of a hump. That hump is not tumor related. You know, sometimes geckos, they just get stumpy. They have like slight kinks or whatever the case is. But as you can see, this gecko is perfectly healthy, perfectly fine. And when it comes to the actual like tumor There's just that one right there. So I could certainly take animals like this that have no issues whatsoever, and like Dr. G said, that would essentially be the ones that you want to breed and try to continue to cross this problem out with. But again, we aren't breeding these guys. We haven't bred these guys since April of 2022, and I have no plans on breeding these guys. I'm just studying these guys, keeping them as pets. I just want to see the results long term of what's going on, and I have no reason to put these guys down. They're very beautiful. There's no issue with them whatsoever. So they will just be staying here. They're not going to go anywhere. I'm not petting them out. I'm not giving them to anyone. I'm not selling them. I'm not making babies and selling them. That's for sure. We already went over all that. So the next two did have slightly larger tumor bumps, like a centimeter or quarter inch, that I would just prefer not to show on camera. But they're not in any places that are, impacting the gecko's health, so they're going to stay alive for now. If it ever gets to a place where it does impact the gecko's health, then we will put those ones down. But this was the next one after that, and you could see just how healthy these are. Now, in Dr. G's original study, he talked about how 80+% did develop the tumors within 6 months to 5 years. But again, the whole 5 years thing, they only bred them for 2.5 years. So how did they have animals that were 5 years old to study? That question is a little bit up in the air. But regardless, they were seeing massive problems within the first 6 months to a year because they were inbreeding so much, and they were trying to make super forms, super lemon frost, and we know now that super lemon frost actually are the ones that have cancer, and so those are the ones you want to avoid. But in their original study, the goal of their study was to produce as many as they could, and so they did under inbreeding circumstances, which is completely opposite of what we were doing with outcrossing the animals and trying to select the healthiest, best animals, right? So again, here's an Afghanicus one, but you can notice thicker skin. And whenever there's thicker skin, that's when you're going to find brighter patches and whatnot. So you can see that one bright dot under the stomach. That's a skin tumor starting to form, right? Underneath the stomach and stuff like that tends to stay just very flat into the body. The only ones that get bulbous are around the cheeks, the ears, the eyes. So, but as of right now, this one has no reason where I need to put him down. Here's another fasciolatus. Thinner skin, not thick skin, less pigment. Very beautiful animal. No white spots. No issues whatsoever with this guy. Again, the no white spots is really what we're going for, because the white spots are what turn into the potential for tumors, right? This guy. So if there's no white spots, then there's no tumors, right? And kind of the good and bad thing with lemon frost is you can see the white spots straight through the skin. And again, only the super versions, according to the doctor's paper, only the super versions, the homozygous versions, 2 copies, actually have cancer. The single copies, such as this, are only prone to produce tumors. But like the paper said, there's still 15 to 20% that don't produce tumors. And that was in the macularis. That wasn't even studying the fasciolatus and turkmenicus, which we are seeing more success with. So if the doctor was to study fasciolatus and turkmenicus, they would probably find some differences in the DNA code that could help them to figuring out what the actual cause is, since, as we went over earlier in this video, they actually didn't have a perfectly fine-tuned cause that they could relate. They just had a simple hypothesis that was an unconclusion. And the doctor even said we would have to study many more geckos in his interview with Strengthen Leos to actually come to a decision on what is the actual cause that's going on here.
So we were not able to identify the mutation. Of course, as we discussed earlier, we will need more animals. Yeah. A lot more animals.
And even then, it's up in the air, right? Because it's science. Sometimes you don't get the answers you're looking for. So that's where observational science comes in, which is what I was trying to do, which was, okay, Lemon frost produces thick skin, short faces, short bodies, and tumors. The Turkmenicus have long faces, thin skin, long bodies, and no tumors. So what is going on there? There's something going on there that was causing for a better result, which is the only reason why I got into the project in the first place. So again, this one is a Turkmenicus. Lemon, no issues. No bright white spots. Beautiful Leo. Another beautiful Fasciolatus Turk. No bright white spots. All ovulating, and you can see I'm not breeding them. Beautiful Leo. Another ovulating girl. Not being bred. Turkmenicus. Lemon frost. Slightly thicker skin than the traditional Fasciolatus ones, but nevertheless, no issues. No bright white spots. Just ovulations and a cute face. Here's an Afghanicus. These were like the last ones to be produced because when I was seeing success with Fasciolatus and stuff, that was where I was focusing originally to start with. But you can see a little bit thicker skin with the Afghanicus, which makes sense because they do have more color naturally, but still no white spots. So the outcrossing definitely does help and work, but really what the doctor was saying, if you watch his video back, is you have to find ones that not only are outcrossed, but also don't have the issue and don't pass on the issue. So according to him, it would have to be a very long study where you studied animals that don't have any issues and you would study that really long term, right? And that's just not something we're gonna do. We already have our 60 or so ones that we're studying, and we have no plans to breed those guys again or do anything with those. We're just gonna observe them, keep them as pets, and report like this. We'll do another report like this maybe 10 years from now, right? Beautiful Fasciolatus. No issues. No white spots, just ovulations, but we're not breeding them. Here you can see what the white spots actually do look like. This one is slightly flat to the skin, but a little bit bulbous. And then you could also see a couple more bright white spots there. So this is like not as bad, obviously, as the ones with the bulbous tumors coming out, but I would consider this bad. In my head, this would be an animal, like if I was continuing the project, this would be an animal that would not be selected for breeding. The only animals that would be selected for breeding would be animals that have no white spots whatsoever. Here's another ovulating girl. Beautiful Turkmenicus. No white spots, but not breeding. Beautiful Fasciolatus. You can see the Fasciolatuses almost have white heads, which would be a cool project to work. If I was working this project, would be like a white head project, right? Where they have a white head but a yellow body and then a white tail again. But look how thin the skin is. This skin looks like a normal leopard gecko. No thickness whatsoever. No bright white spots whatsoever. And this is a male. So if I was working the project, this male would be a great candidate to breed on if he did not express any symptoms within the next like 5 years. But again, we are not breeding these guys, have no plans to breed these guys, and I don't think these guys would ever be accepted. Even if somebody was to continue breeding them, you're only really gonna hurt yourself by publicly working with these guys and associating with them. I just already have these guys, and a lot of people are curious about like why I bred them in the first place and what the results were. So in conclusion, I want to show that off and give everybody that kind of closure. But beautiful animal, beautiful eyes, no issues whatsoever. All right, here's one of the original Turkmenicus males. So this was a 3rd generation Turkmenicus male that we brought in. And you can see that he has that one bright spot right there, but that's it. And other than that, oh, he has a little one on his lip. Very small, bright white spot on his lip. But other than that, there's nothing bulbous, nothing protruding, nothing crazy to where this guy has any issues or any pain whatsoever. So again, just a pet. Here's another Fasciolatus male. Thin skin, no white spots, no bulbous tumors, no white spots anywhere. beautiful, beautiful animal. There's one thing that people cannot deny is that when a lemon frost does not have tumors, it certainly is a striking, striking animal, especially in the eyes, which are like this pure white and black. Looks really crazy. But again, you can't work with these guys. They're like kryptonite for sure. You don't want to work with these guys. Another fasciolatus one. No issues. No bright white spots. The bright white spots are a big deal, guys. That's why I keep harping on the bright white spots, because they are the prerequisite to tumors. Like, you don't get tumors without bright white spots. So with no bright white spots, in theory, there should be no tumors, as long as you don't have super lemon frost. But every super lemon frost has white spots and tumors. I've never seen any super lemon frost that does not have white spots and tumors. There's those striking eyes. All right, hang with me, guys. I think we got like 16 more here. So here is another one. This is a macularis back cross. So you could kind of see the tumor growth on the edge of the lip there. But again, there's nothing on this animal that is actually preventing it or giving it pain or anything like that. If it did get to a point where I thought that was the case, then I would put it down. And even some of the animals that I put down, I don't think that they were truly like going through pain, but it started to look really bad, right? Like a big tumor here, a big tumor there. And to us as humans, we associate that with pain or suffering. So I just thought it was best to really put those animals down, you know? You can see white spots under the belly, but this would be a guy that I would keep a close eye on and might get put down one day. But again, the original intent of the study was to find animals that don't have any white spots whatsoever. And it seems like with the fasciolatus outcrosses especially, we accomplished that like sevenfold, like so much better percentage than what they experienced in the UCLA study with working with only macularis, right? And we only produced 70 or so, right? And so that's still kind of like a small group to observe, but of that 70, there was really good results. Another female ovulating, no white spots, no thick skin. So this is either a Turkmenicus one or a Fascio Turkmenicus. Very cool little baby. Not a baby, I just call all my geckos babies. No issues, no white spots. Okay, the next one was an Afghanicus that had a bigger one on its chin, but it's not affecting like any livelihood of the animal right now. I just obviously don't want to show something that's visually sensitive like that on camera. But you can see right here, bright white spot on this Afghanicus. And again, those big bright white spots, notice every time I say that, it's on an Afghanicus or a macularis. And you can see one like bright spot right there, kind of like near the base of the back there. And you can see other than that, nothing really big or bad or anything. But obviously, this is a little bit of a younger animal. So if things did get worse with this one, we would certainly, look to humanely put it down, because we wouldn't want it living in that condition. Even though the Finland study showed that when they studied the superficial tumors on the geckos' bodies, that it was not painful to the animal. I can't prove that, obviously. I don't know what metrics they went through to make that claim. And it just sounds like an insensitive statement to make, but it is the statement that they made. I'll leave a link to it in the description so that you can also read what they wrote, if you even care. The reason I didn't put a lot of emphasis into that is because, like, who cares? If a Finnish study said that a tumor is not painful to an animal, nobody's going to care about that, because everybody's thinking, like, how would the scientists know that, right? So that's why I don't put a lot of time into that. Right here, you can see this is a Turkmenicus one. 2 bright spots right there, 2 tumors right there. But again, the biggest thing is on the face, on the chin. Those are the ones that really become bulbous and cause issue. So that's what we mainly keep an eye out for. This guy, I have no reason to put this guy down. Perfectly healthy, fine, interacting gecko. Licks you when you touch him under the chin. He's good. I did skip over 2 Afghanicuses that did have a larger bright spot than I would like to show on camera, because I'm not trying to show like negative things on camera or what could be perceived really negative, but I do want to document that for you guys. The only reason I'm keeping them alive is because I don't deem it to be something that's really in the way of the gecko's life or anything like that. Here's another Turkmenicus one. Beautiful. No white spots. No issues. Couple years old already. Beautiful white eyes. Here's another girl ovulating. No white spots. Not breeding. And as you can see, beautiful gecko. No issues whatsoever. No reason to put this gecko down. This was probably the one that I bred to the Black Knight. So she's a little smaller, but she's a dark Turkmenicus. Lemon frost. No bright spots. She's ovulating, not breeding. But look how dark she is. So that's why I bred a Black Knight to her. And that's why I produced like those one or two that I showed earlier. Just out of curiosity. So, really beautiful gecko. The dark ones, you could really see like the brightness of eyes, right? All right, we are coming down to the last 6 or 7 here. So here is a macularis one, and you can see a lot of thicker skin, right? You can see the difference in thickness of skin and almost like shortness of face and like the buggier eyes. Those are things that you don't want to look for. But again, I had to produce a couple of these so that I can compare them morphologically and phenotypically to what I'm seeing in the Turkmenicus, Fasciolatus, and Afghanicus. But no issues right now with this guy, so no reason to put this little one down. Not right now. All right, this is probably one of my favorites. It's kind of like this light yellow phase kind of thing. And that was a trait passed down from one of the dads that did have this like kind of light yellow phase to it, which we were studying to see if that was a different genetic trait that we were observing in the animal. And he did pass on that look to a couple of his babies where they're kind of like that lighter yellow. So this is a Turkmenicus lighter yellow phase, but no white spots, ovulating, but we're not breeding. Perfectly healthy jawline, face, all that kind of stuff. So the Afghanicus ones are really interesting. They have like these dark eyelids that kind of make them look like they have mascara on. So again, the Afghanicus is like the one I don't recommend. You can see bright white, even as young as this gecko is, bright, like being on the younger side, and it already has those bright white. In my observation, Afghanicus and macularis are worse, and Turkmenicus and Fasciolatus is by far the best. All right, closing in on the last few here. Here's another Turkmenicus. Hi, little one. Nothing, no issues. Maybe a little thicker, like brightness there, but no, not in person. It's not anything like iridophore related. You know, sometimes geckos just have brighter patches of white. Like if you look on any gecko, even a tangerine or something, they will have brighter patches of white on their chin, which actually might be a reason why the chin and the ears and stuff is the worst demonstrations of the tumors, is because all leopard geckos, look at any leopard gecko you got right now, has whiter chins right here. And so maybe there's more whiter cells that are there like in those chin areas. But I can tell you that this is, like, if you see any brightness right there, that's not the tumor or anything to do with the tumor. All leopard geckos have that. And if it did have tumors, you would see it all over its belly, its body. So, good gecko again. Here's a good example of that. So, you can see this gecko right here has like whiter, thicker skin underneath its chin on this side. So this would definitely be a gecko that we observe. You know what I mean? But again, there's no reason to put this gecko down right now. It's perfectly fine and good. No white spots under the belly whatsoever. So again, usually they form it in the chin, or like under the belly, they will have like white spots that usually don't become bulbous. They just stay kind of flat to the belly. But the chin ones are the ones that usually become bulbous. Maybe that's because genetically in the genome of a leopard gecko, there's more white pigment cells there. I don't know, but that could be a reason why we see the worst cases on the chin. So here's another Afghanicus, and you can see a little whiteness forming right there. There's a little bit of a bump right there. So again, Afghanicus, no good. This is not what we wanted to see. We were hoping Afghanicus, we think, is like the furthest. We think Afghanicus should be classified as a separate species of leopard gecko, and Turkmenicus should be classified as a subspecies, because Afghanicus is way different than all the other subspecies of leopard geckos that breed together. So we were kind of hoping that Afghanicus would provide the solution, but we found out it's actually worse. It's the same as Macularis because of the color. The animals that have more saturation and more color, for whatever reason, those are the ones that express the worst issues. And so Turkmenicus and Fasciolatus have less pigmentation cells. And because they have less pigmentation cells, they are the best. And Fasciolatus has the least amount of pigmentation cells of all leopard gecko species and subspecies. So that's why we think, in our observation, we found the best results with Fasciolatus. Okay, and last but certainly not least, a Fasciolatus male, which also is very nice. And if we were to breed, he would be a male that we would study because, well, actually he has one white spot right there. So I take that back. He would not be a male that we would try to breed or study because he does have one super, super light white spot, which I am having trouble showing. Can you see it? Can you see it right there? It's very superficial. It's not bulbousy whatsoever, but it is, nevertheless, a blemish. But he doesn't have anything on his chin, face, eyes, so he would almost make a good candidate if we were continuing the study. But we would obviously look to find geckos that had no issues whatsoever for, you know, like 5 to 10 years. But again, we just have no plans on breeding these guys again. I don't think it's worth it. You know what I mean? We have a huge love for people in this hobby and desire to like collaborate and work with people, and you just can't do that if you are publicly working with these guys and like promoting them. So I feel like the nail is in the coffin. It's done for us. I just want to give these guys as good of a home here with us only as they can, because as you can see, there is no suffering going on here whatsoever. These are all single copy lemon frost, no homozygous, no super lemon frost, and according to the 900 animals that were studied by Dr. G, only the homozygous ones actually have cancer, and the single copy ones only produce moles or tumors. And see, that's so small, I would just call that a mole, right? I have a mole on my face right there. That black mole, that is a cluster of dark pigment cells that are not dying off like they should be. And that's what a mole is. And so these guys just have iridophores, or white reflective cells that don't die off, which is why all their tumors are white. And other than that, I think that is everything. So let me know if I missed anything. I feel like this will probably be my last lemon frost video ever. I really don't have a reason to do any more lemon frost stuff. I just wanted to give closure and context to everything that we've done over here in that, basically that 1 year, from February of 21 to April of 22. That was the only breeding that took place here, and we are currently not breeding them anymore. We obviously got them separated on a completely different rack, a completely different section. They're not breeding, we're not breeding any of them, and we have no plans to as well. We just don't want to cull these guys because they are healthy. Like, they are good pets and animals, and maybe we'll even bring them to events and stuff like that where we can educate people on why not to breed lemon frost or get into lemon frost or be aware of what one looks like in case someone's trying to sell you one. So anyway, that is it, guys. I hope you guys can let me know what you think in a comment below. I hope to talk with many of you and answer any questions or anything like that if I can for you guys. So until next time, my friends, stay safe, feed your reptile passion, and have a geeky gecko great day. Peace.